Hello, hello, hello. Welcome to Honors Physics Lesson 1.6, Graphing Position, Velocity, and Acceleration. Alright, so take a look here. If you were in class, I was just saying, hey, look at this graph and circle where we have acceleration. So I'm going to go ahead and do that for us here. So this is a velocity time graph. So velocity over time. So v over t, which gives us acceleration. So whenever we have a slope, we have acceleration. Both a positive and a negative. Anytime that we have no slope, m equals 0, we have no acceleration. Alright, so take a look at this. This one has us calculating our acceleration. So what we can go ahead and do, and how about we just do this section right here. And this is what some of the questions we were doing on our homework. So what we need to do is find our initial position. So 6, 7, 8, 9. So we have negative 9 meters per second. And then we have 10, 11, 12 meters per second, positive 12 meters per second. So this is our velocity initial. This is our velocity final. Our acceleration should equal, and that's supposed to be meters per second. I don't know why it looks like mx. That's meters per second. There we go. Our acceleration should be final velocity 12 minus our initial negative 9 over our total time, which in this case was 7 seconds. And we should get an acceleration of 3 meters per second squared. Alright, so let's take a look at this squiggle monster right here. Now this is not a velocity time graph. This, boys and girls, is a position time graph. So delta x versus time. Alright, so circling acceleration. So with a position time graph, we're going to have acceleration wherever we have a curve. The curve indicates that we have a exponential change in our position. And these parts, whether it's flat or if we have a straight slope, we have no acceleration because we have a constant velocity. Alright, so let's see where we are with a practice problem. So we have Chester. He's at his house at a position of 0. So delta x, or not delta x, just xi equals 0 meters. He's at rest, so his velocity initial equals 0 meters per second. He begins accelerating east, so we have a positive acceleration of 5 meters per second squared for a time of 6 seconds. Then, after that, he drives at a constant velocity, so whatever velocity he reaches. For 4 seconds. Make position, acceleration, velocity, and position time graphs. So, here's what we have. We'll start with an acceleration graph. This is the easiest one to do. Time goes over here on the x-axis, and we're at 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our acceleration goes all the way up to a nice 5. So 1, 2, 3, 4, 5. Right? For the first 6 seconds, we have a acceleration which is constant of 5 meters per second squared. Then we have no acceleration. And since we're just doing constant acceleration, we're not going to have any change here. It's just going to be an instantaneous switch. So you were accelerating, and now you're not. Yay. And that's what your graph will always look like for acceleration time, just a straight line. All right, velocity time graph. So velocity time graph, what we're going to have here is how our velocity changes over time. So same time goes over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our velocity, however, needs to go up. Let's say it's going up by 5 meters per second, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. This is meters per second. This is just seconds. To make a position time graph or velocity time graph, given this information, for the first 6 seconds we have an acceleration. So every second it goes up 5 meters per second, right? So 5 meters, 5 meters, 5 meters, 5 meters, all the way up, oops, to 60. How about I make that a nice straight line instead of this shusha pusha pusha that it is. And yes, I just made up that terminology. It means terrible in my book. There we go. So after 6 seconds, we went up to 30 meters per second. So this slope, this area right here, ends up being our acceleration, which is our 5 meters per second. Excellent. Yay. Rise over run. Who can complain? But then, we're at a constant velocity for the last 4 seconds. So there's our constant velocity graph. All right. I'm going to pause. I'm already getting to 7.5 minutes here. And then I'll make another video that has position time. So I'll jump right into position time based on this information. But I got to break it up. Sorry. Get to the next video.